In this video, we will write a count sort function. So already I have a main function and a list of elements available. Now here I will write down a function for count sort. Count sort, it takes an array of elements as well as the number of elements. Now here inside this I need few variables I, j and max for finding the maximum element, and also counting the elements I need a count array, so for that I'll take a pointer. Now the first thing is I should find out the maximum element in the list. So for that I will write a function to find max. I'll pass an array and the number of elements n. So let us write down the function here. For finding a maximum element, I should have a minimum element. So int 32 underscore min, this will be a minimum element, integer element. Then I need I for scanning through this list. So for I, assign 0, I is less than n, and I plus plus, if any element from an array is greater than max, then we will change max to that element. So already we have the smallest element, so we can find out maximum element, return max. So this function will find out the maximum element from a array. Now here inside count sort we will create an array of that size. So cassign integer type array malloc function, and this should be size of integer, and this should be multiplied by max plus 1, as we need an index up to that number, that is maximum number, because the indices start from 0, so we should take one extra. Like if you want 10th index, then you should take size of array as 11, so you get indices from 0 to 10. Then this array should be initialized, so I assign 0, I is less than n, sorry, max plus 1, and I plus plus. So the C array should be initialized with 0. All the elements are initialized. Count is initialized to 0. Now we have to scan through this array, that is A, that is being passed. So we will scan through this one for I assign 0, I is less than n for n elements, I plus plus, and wherever the element is found, so in C of A of I, we will do plus plus increment if the element is found. Then we have to scan through both the arrays I, that is A and C. So I assign 0 and J also assign 0. Now while J is less than max plus 1 till the end of the C array, we will check if C of J is greater than 0, means it is not 0, means there are definitely some element. So at A of I, we will copy that J element, and also we will decrement the count of that J. So J minus minus. So I have used I for our array A and J for this C. Okay. So the variable names. And if J is greater than 0, we will do this. Otherwise, we will increment J. So J plus plus. And that's all. This will sort the array A. So from here, I will call count sort function by passing array A, and the number of elements are n. Yes. Let us run the program and check. Oops, we got an error. Let us see what is the reason of this error. C is null. C is null. And this A is having element 11. Okay, perfect. Then this is 0 and this is null. It is giving null. Okay, so it means C is not assigned any array. We are creating an array. So let us see what the problem is there in that array creation process. Okay, malloc we have not included. It's a warning, so it will implicitly declare, so we need not go and go there and write on stdlib. Max plus 1, this should be inside bracket. Then what is the value in max? Oh, some large value. So, okay, yes. I have written a function for finding max, but I did not call that function. Yes, I missed that statement. So, find max, I should send an array and the number of elements n. So, max I found out. Let us check the code once again before executing it. This is initializing an array and this is called incrementing all the values. Then I is for array a, j is for that is count array. And when element is count value is greater than 0, then copy the element in name of I. Oh, I plus plus also I should do. That is j element is copied and c of j is reduced so that it becomes 0 and we continue upon the next element. Yes, everything is perfect. Yeah, I plus plus here, it was missing. That's all. Let us run this now. Yes, perfect. 3, 5, 7, 9, 10, 11, 12, 13, 16, and 24. So it's working perfectly. So this is the count sort procedure. So this is a faster sorting algorithm that takes order of n time, but it takes a lot of space. That's all in this video.